Okay, today we are going to go over lesson 2.1. We're going to be talking about identifying whether or not relations are functions. We're going to go over how to find your domain and range. We're going to classify functions as either discrete or continuous, and we will finish off by evaluating functions. We should have this done in 2 videos here, so we're just going to jump right in. So starting out with, we got a bunch of phrases, vocabulary that we need to have. So relations are a relationship between sets of values. In math, when we are dealing with relations, we are dealing with sets of ordered pairs. So ordered pairs would just be points. So anything that is in an x, y form. Okay? Now, the set of all x coordinates. When I am talking about x coordinates, we are referring to the domain of a function. Okay? Another word for your x coordinates of the ordered pairs in a relation, okay, would be your input value. Now, as you guys are working through these, something that you guys should know, x coordinates, domain, and input values can all be used interchangeably. So if I ask you guys a question and I say, hey, what's the domain of this function? You guys could simply say, well, the x coordinates are 5, 3, whatever. And that is correct. You could say the input values are 5, 3, whatever. They're all used interchangeably. Domain, x coordinates, and input values are all the same thing. Okay? Now, the other one we have is our y coordinates. So what are the y coordinates called? Well, the y coordinates are referred to as your range values. So y's are the same as your ranges. Okay? Another word you could use for range is your output values. Range could also be referred to as your output values. And just as they are with a domain, okay, the range can be used interchangeably with y coordinates and output values. Okay? So a potential test question that I could ask you guys is, what are 2 other ways or 2 other words that you could use to talk about the range? And your answer for that would be y coordinates and output values. Or I could say, what are 2 other words you could use to talk about input values? You could then say domain and x coordinates. Okay, so those are used interchangeably. And then finally, the last thing up here, we have a function. Okay, and this is important. You are going to have to be able to recite this to me on your test. Okay, a function. I will ask you simply, what is a function? Well, a function is a relation. It is a specific type of relation in which each element of the domain is paired with only one element in the range. Okay, now that's kind of a little bit wordy. So kind of simply put, if I ask you on the test, what is a function? Well, it is a relation where each input has only one output. Okay? A relation where each input has only one output. Okay? So if we're going through and doing this, remember we talked about input and output as interchangeable. I could say a relation where each x value has only one y value. A relation where each domain has only one range. Either way will work for this definition of a function. Okay? But that is very important to know. Now, there are 3 different ways that you guys will see functions represented. You will see functions represented in a table. Okay? You will see functions represented by graphs. We are used to seeing both of these here. The other way we will see functions represented is through mapping, which is just showing what number goes with which. So these 3 pictures up here are 3 different ways that you guys can represent the exact same function. Okay? And you guys will notice I've got a table with x and y. Okay? So that's the point, -5, 4. And we also are mapping that if our input value, because remember x is our input, if we have an input value of -5, the output will be 4. So these three things up here are three different ways that we can represent functions, and they are all representing the exact same function. Okay? So how can we, by looking at these, tell if something is a function? Okay? So which of these things up here depict a function? Well, in order to tell, you guys are going to have to recall the definition of a function. Okay? So what is a function? Well, it is where each input has only one output. Each input can have only one output. So this example over here, okay, is this a function? Well, the input of 3 has only a 7 for the output. The input of 4 has only an 8 for the output. The input of 5 has only a 9 for the output. So the answer to that question is for this one here, yes, each of those inputs only have one output. So this here on the right is a function. Okay? Now there's something else we're going to answer about that, but we will come back to that. Okay? So I want you guys to pause the video here. Pause the video, look at this table, look at this map here, and I want you guys to tell me, is it a function or is it not a function? Okay, so you should have paused the video there. Let's look at this example here. Is this example on the left a function? Well, our 2 has only one output. Okay, so we're good with that one, right? Now we have an input value of -6, and -6 has 2 outputs. So therefore, it is not a function. This is not a function. Why is this not a function? Well, it is not a function because input -6 has 2 outputs. So the -6 is the reason that that is not a function. Okay? Looking at our next here, we have this table. Okay? All right, we got a table here. It's honestly kind of hard to tell if something is an input or if something is a function based on the table. Basically, you're going to check, does 4 have one output? Yes. So I need to look, are there any more 4s here on the x's? Well, there's a -4, but no. Okay? -4 goes to -3, so -4 only has one output. 1 goes to 3, -1 goes to 3, so -1 has only one output. 1 goes to 2, so 1 has only one output. So if I were to draw this in a K-map, you guys could see you'd have 4, -1, 1, and 4. Okay? 4 goes to 2, 3, and -3. Okay, there's only 2 there. So 4 goes to 2, -1 goes to 3, 1 goes to 2, 4 goes to -3. So the fact that we have 2 numbers going to 2 is usually what kind of raises alarm for kids. They're like, well, is that a function? I don't know. Is it? Well, 4 has only one output. And 1 has only one output. So this situation here where they're going to the same number is okay. This table here does represent a function. Okay? And the reason that this one is okay is because each input can only have one output. So yes, this output has 2 inputs, but that's okay. Each input can only have one output. Okay? You guys could actually have a K-map that looks like this, where you've got 1, 2, 3, and 4, and you've got 5 right here. And they can all go to 5. That is okay because each of those X values, each of those inputs has only one output. Okay? Now, the last thing this is going to ask you guys to do is, after you decide if it's a function or not, is you are going to have to give the domain and range. So let's remember, domain is just another way of saying x values. And range is just another way of saying y values. Okay? So for this one here, my x values, they'll always start on the left. So to answer that question, I can just write my domain. So D, put a colon, and you've got 2 and -6. My range, your y values, will always be over here on the right side. Okay, I'm just going to write my range is 3, 7, and 8. And there's my domain and range for that map there. Okay, this one's already in a column for you here. You guys can see there's your domain values. There are your range values. So I would write D. And then for me, I like to put them in order. So I would write -4, -1, 1, and 4. Okay, you don't have to do that. Range values, we've got -3, 2, and there's 2 2s, but I don't need to write a 2 twice. Okay, so once we've got that 1, and then we got 3. So there's our domain and range for that one there. Okay, again, remember the left here is your x's, the right here is your y's. So my domain for this one is just 3, 4, and 5. My range for this one is 7, 8, and 9. So that is finding your domain and range for each of these here. Okay, we will have one more video to finish off these notes.